1969. That was an interesting year. There were men on the moon, Concorde flew for the first time, the jumbo jet took to the air for the first time, Woodstock was going on, the Beatles were splitting up, and the Easy Riders, the movie, was in cinemas. And while all that was going on, Soichiro Honda introduced his CB750-4. It's hard to imagine how exotic the CB750 was in 1969 because its basic layout came to be called the Universal Japanese Motorcycle, where 4 cylinders, overhead cams, 750,000 cc's for the period, excellent brakes, although with hindsight perhaps not quite so excellent. And it was a revelation. Fairly shortly after the introduction of the CB750, the aftermarket chopper industry really got rolling. That's not to say it hadn't been around before, because obviously somebody built the bikes that were an Easy Rider. And you could buy frames for Triumph engines, frames for Harley engines, and you could buy frames for Honda CB750 engines. So since 2019 was the 50th anniversary of much of that, we thought we'd build a 50th anniversary replica type frame in 2019, but we didn't, because it's now 2020. So this is where we build the 51st anniversary replica Honda CB750 Chopper frame. In a normal course of events, the way I go about building a frame is I arrange the parts in space, I measure them up, set the jig up to suit those measurements, and then put the engine on the jig, wrap some tube around it, and that's the frame. But a lot of people inquire about plans for frames. Where do I get plans for this, plans for that? Well, if nobody's taken the trouble to draw the plan up, then good luck to you. But as it happens, I know where there was a set of plans for 1970s Honda CB750 chopper frame, and that's on hondachopper.com, the link to which should be in the description box down there. They were drawn up by a chap that I spoke to a few times in my life, Frank Wu. Great guy, fortunately he's no longer with us. So I downloaded the plans from hondachopper.com and started taking a look at them. First thing I noticed was that the radius of the bends was 2.5 inches, the root radius, and the bends I can make in inch tube currently are 3.5 inch. The root radius is to there is 3.5 inches on that. So that doesn't comply with the drawing. Now the problem is that the front engine mounts are then based off of the radius that the tube's bent to in the plans. So I've had to redraw that. The rear axle slots were 5/8 of an inch, and my axle in my CB750 back wheel is 20 millimeters. So I had to redraw that. And I've altered the top tube diameter as well to 1.5 inches from 1.25 inches because I prefer that. It just makes for a stiffer frame. So there's the first problem you've got. The plans aren't necessarily drawn to suit the equipment you have. So aside from equipment, what else have we got? Well, there's the aforementioned CB750 single overhead cam engine, which we have one of. There's a set of, I'm going to just measure this a second. There's a set of what appear to be 8-inch over CB750 forks, which have been fitted with a Brembo 4-pot caliper, which is probably better than what was on there. And there's a CB750 back wheel, drum brake, K-series with a 16-inch rim height. So what we really need is a frame to connect that together. But to make the frame, we need a steering head, we need a set of axle plates, we need to bend some tube, and we need some way of getting everything lined up. So that's basically what the 51st anniversary CB750 frames project is all about. So let's get on with it. This is a bit of tube 3/8 diameter, 3/8 wool tube. It's seamless dome if you're American. And that means it's too big. It's bigger than the bearing. The bearing's too big to fall down the middle of it. Both the bearings are the same size on that race. So This is what we'll be using for a steering head once I've figured out the length. So we've got this fairly long CB750 front end to go on this frame that we're eventually going to arrive at. But it's going to need a headstock fit. I don't have one, so let's just measure this up. Working in inches, I make that 7 1/8. So we'll go with 7 1/8. So why seamless tube? Well, you don't really want your steering head to split along its length under the load, so best if it hasn't got a weld in it like ERW does. Why not use billet? Well, apart from the fact you've got to bore a hole up the middle of it, a lot of billet steels contain lead in the alloy to promote free cutting when they're machined, and lead, whilst it promotes free cutting in machining, also promotes undercutting welds, and since the steering head is the most highly stressed part of the frame, you don't really want undercut welds because it can lead to the steering head falling off, which is both unfortunate and embarrassing. I'm cutting this on the reciprocating hacksaw rather than a cut-off saw. Why am I doing that? Well, it leaves a square end. Usually not much to choose in it, but it's there and it's less noisy, and I had a hangover. So really, just use that. Once it's cut to length, take the piece of tube and deburr it using a file. This is so that the lathe can catch hold of it and have a reasonable chance of it running something concentric with the axis of the lathe. There you go, inside out. That's far too much overhang, but the lathe's running quite slowly, so if it does fall off, there's not much chance of it having enough kinetic energy to disappear out my nose. That's a steady rest, and I'm got to tell you, I'm not a machinist and I don't even play well on TV, so I'm kind of winging this a little bit. I'm adjusting the steady rest here, trying to get the run out down to nothing, or as near nothing as makes no odds. That particular rest has brass or phosphor bronze probably rubbing pads on it rather than bearings, so that it needs lubricating quite frequently, which is what I'm doing here. Once that's all set up, and of course I ran it in with a dial gauge, and you didn't see that because I didn't film it. Set the steady rest in a sensible place where it's gonna stay. Wind the tool post back so that the tool's got some chance of cutting the end of the tube. Here I'm using the power feed on the cross slide to face the end of the steering head off. So the tool's arranged across the axis of the lathe. So take a cut, wind it back by hand, switch the lathe off, measure it with the same steel rule that I used to measure the length of the fork yokes or triple trees. There's no need for it to be any more accurate than that really, because at the end of the day I took the measurement that I'm using with the ruler and I'm measuring the workpiece with the ruler, so it's going to come out close enough for government work. It's a little bit long, so whack another cut off of there. Keep it lubricated with the oil can, because dragging the lathe out from the wall to fix the coolant pump just seems like too much effort at the moment. And there we go. Knock the power feed out. Go on, there we go. Power feed out, wind it back by hand. Knock the clutch out, stop the workpiece, measure it again. Oh, look at that, there we go, that'll do. Right, I've taken the facing tool out of the tool post, replaced it with a boring tool which is mounted along the axis of the lathe rather than across it. This time I'm using the top slide to do the depth of the cut, and I'm using the cross slide to control the diameter. It's a fairly critical point about all this, is that the top slide is sitting on a micrometer stop, which you can't see. And what that does is it lets me wind the saddle back when I'm happy about how deep I've machined the bearing cup recess. Pull, come on, knock the clutch out, get the bird's nest out of the part, and if you look by the tin of WD-40, there's the micrometer stop. So when I've measured it with the vernier calipers and worked out how much more I need to
wind the cross slide across. Then when I bang the saddlebag down, it goes back in the same place. So my reference on the top slide for the depth of cut is still there. Just repeat until the bearing feels something like it's going to fit in there. I think I was working on 1,000 per inch. It's about 2-inch bearing, so it's probably a couple of thou undersize. Flip the thing round and machine the other end. Once both bearing recesses are machined, I take a carbide burr and I put a notch inside. That's so that in the event that you ever need to change the bearings, you can get a drift in there and knock the bearing out without having to weld the race or anything stupid, which it leaves you with a chance of damaging the paint if nothing else.
Right, well, there you go. One steering head with taper roller bearings in it. That is probably the most difficult part to make yourself if you don't have access to a lathe. The material's expensive because you really do need to be doing that in seamless tube. It's thick walled, but with the advantage we have these days is that you've got online metal suppliers who will sell you a foot of it or whatever you need. I would advise you to buy at least enough to make 2, because that way you've got more of a chance of it going right both times. So that's got that ball rolling. We've had a few things for it. We've got most of the components together. We just need to start building a frame. So the idea here is that we're going to make, or I'm going to make, possibly with a little assistance, a series of videos at the end of which we have a rolling chassis for a CB750 frame. I don't want you to get the idea we're going to build a complete motorcycle, because I can't afford it at this point. I need a set of carburetors for the engine. I haven't got them, can't afford them. I can make the oil tank, I can make the battery box, I can make the electrics box, I can even make the fuel tank, perhaps even make the mudguards, but there's still other stuff that's going to need that costs more money than I've got to throw at it. So please do not expect to see a running, finished CB750 at the end of this. What we're going to be looking at is a rolling chassis. Moving on from there, what we'll probably do is take something that does go. I have to go and buy it probably, but I can take something that does go and have a look at how we go about building a frame for something without using a set of plans, which is a bit different. Those two things aside, I don't want to make a video about how to make a frame and then try and explain to you how to do, for instance, tube miters in the same video, because it gets too long, it's too much information to take on all at once. So what I should do is I shall make a video on, for instance, tube mitering, and then we'll do some more basic metalwork videos on marking out and general workshoppery stuff. So if you like that idea, perhaps you care to subscribe, you'll hit the little bell so that you get the notifications, and I'll see you in the next one. Take care, bye.